Hi guys, a short video on the 2015 paper 2 coordinate geometry questions for junior cert higher level. So it's coordinate geometry. There's two questions, question 5 and 6. So we're going to take a look at these. And in question 5 here we've been asked at the start, we'll be given a diagram as you can see, and the question tells us the coordinate diagram below shows the lines N, P, R and S, and the table shows the equations of each line, but so far we don't know which equation is for which line. Now we can see from the equation, the green equation there, slope is 2, the intercept is -4, and we know that because we always have this equation of a line in the slope intercept form. Okay, so mx, that m is the slope, is the coefficient of x, and c is the intercept. That's where the line will cross the y-axis. Now notice that in this equation that the y is on its own with 1y, it's an invisible 1 of course, and it's a positive 1y as well. So you have to have positive 1y on its own, isolated on the left or whatever, equal to mx plus c on the other side. So the slope is the coefficient of x and c is the intercept. So all of these equations that we've given us, we can see it's 1y and it's a positive 1y, so they're ready to figure out the slope and intercept. So m is just that bit there, isn't it? That's the m. And so we can see the slope is 2, and we can see then that the intercept is the c part, just there, that bit there is the intercept. So we can see where we're getting the slope is 2, m is 2, the slope is m, the intercept c is -4. Similarly for the next one, you can see the slope is definitely 1 because we've got an invisible coefficient of 1 there, and it's a positive 1. And not as easy to see maybe is the intercept is missing, or 0 in other words, that's why it's missing, it's 0. Similarly in the next one, the intercept is 0, and this time we can see the coefficient of x is a -1. Again, there's an invisible 1 there in front of the x, so it's -1. So you can see slope -1, intercept 0. And the last one, the slope is 2 and the intercept is 4. This and this will be the easiest to identify, perhaps, and we'll just take a little look at a diagram for that. So remember, slope is n, intercept is c, and we've got this diagram here for that equation y equals x. Now I've drawn the diagram twice without an x and y axis. We can see basically what does the slope of 1 really mean. Well, it means rise over run 1 over 1. So could be m equals 1 over 1. The rise is always the vertical, dozens, while the run is always the horizontals. So, or if we redraw it, some people might prefer to see it like that, where you can see it's going up 3 and going across 3. So up 3 and across 3, the rise is 3 and the run is 3. 3 divided by 3 is 1, so still a slope of 1. So why is that so easy to identify? You can see that the wine coloured line always makes a diagonal, and it's kind of going across the corners of each box, and it's not climbing 2 boxes while going across 1 box. It goes across 1 box and up 1 box. So that's kind of easy to identify. Our wine coloured line must be n, because it's going diagonally like that, across 1 box, up 1 box, across 1, up 1, across 1, up 1, has a slope of 1. Or if you prefer, you could pick out goes across 3 and up 3, so the slope 3 divided by 3 is 1. So definitely we can identify n, nice and easy. In the same way, we have drawn here a line with a slope of -1. We can see that again it does that diagonal thing across boxes, and it has, fall of 1 and a run of 1. They often call it the rise over the run or the fall over the run. So it's falls 1, goes across 1, falls 1, goes across 1. Or in this case here, it's falling 3 and it's got a run, falling 4 I meant to say, and a run of 4. So it's falling 4 boxes and a run of 4 boxes. So -4 divided by 4 is -1. So slope of -1 should look like that. So again, that's kind of easy. It's the only negative slope there. It's certainly the easiest to identify. S has to be our blue line, our blue equation. So with P and R left, we've got to figure out which is which. Now they both have a slope of 2. Looking at our green line there, or our orange line, what does the slope of 2 look like, and so on. Let's have a little peek at a diagram. So good to look at the intercept first. We've highlighted that in pink. So the intercept there is the -4, and see that's down the bottom there. That's where it crosses the y-axis. So the intercept is kind of simple enough. The slope, the combination of a rise and a run, just there along there. Okay, so it's always a run of 1 horizontally and a rise of 2 vertically, and that makes pretty good sense, I think. Now when you contrast this diagram to the diagram we had over there, we can see that this is our wine colored line is 4 boxes down here. Now none of our lines over here are 4 boxes down, and how can we account for that? So it must be a different scale. But when I contrast P and R and try to figure out which is the green and which is the orange equation, we can see that the line P crosses in the positive sense of the y-axis, or the positive area. So P must be our orange line, because it's crossing in the positive area. R must be our green equation because it's crossing in the negative area. You might think, well, isn't it supposed to be -4 and that looks like -2? Well, there's no scale here, guys, so that could be -2, that could be -4, -6, and so on. +2 and a +4, +6, and so on. And so we can see here, this seems to make sense. The intercept is a +4. That ticks for P. And the intercept here is -4, and that ticks the box for R. So it looks like we have found our equations, and we have a reason to distinguish between P and R. Okay. Write the letters N, P, and R in our box. We've done that. Complete the following sentences. Write one of the letters N, P, R, or S in each box. You can translate. You can use a translation to map the line. I'm saying P onto R. Translation would move P over to R. Does that make sense? Yes, you can just translate straight across like that. Any point on P will end up over there at R by moving 2 spaces to the right. You can see our arrows are nice translation arrows that will carry us from P across to R. So I hope that makes sense. For our translations, probably don't need this in our way, guys. So you can use an axial symmetry in the y-axis to map the line S onto the line N. So an axial symmetry in the y-axis. So if we took S and we went 2 here and equal distance out the other side, so it's like the y-axis is like a mirror now. Similarly, if I took this point and go 2 across to the mirror, means I'm going to have to come out 2 on the other side and I end up on N. If I take this part of S and I go across to the mirror and another 2 spaces out the other side, so you can see we're going 4 spaces to the mirror, 4 spaces beyond the mirror, all the time taking points on S through the mirror to the other side where they become N. So hopefully that makes sense too. Right. The line N is mapped onto itself under central symmetry in the point 0. So let's look at N. Okay, so we're only looking at N now. If I take any point in N, let's say I take this point here and I move it, as you can see, 2 diagonals across to our origin, and therefore 2 boxes out the other side, I still stay on N. Would that be true for every point in N? If I take this point here, I go 1, 2, 3 diagonals into the origin, I go 1, 2, 3 diagonals away from the origin, I end up still on N. So we can see that any point on N, if it travels through the origin 0, 0, it comes back out the same distance onto N again. Okay, this question 6 here. The equation of the line L is 5 plus y minus 2x equals 0. Find the coordinates of the points where L cuts the axis. In our little diagram earlier, you may have noticed that we labelled the x-axis with y equals 0 and the y-axis with x equals 0 for a good reason. If we do that and we have that habit all the time, we will remember that every coordinate on the x-axis has a y equals 0. Every point on the y-axis has an x value of 0. So with those filled in, it should be easier now to work with our formula for this particular line and get a solution. So we're saying y is equal to 0 here, so this y is becoming 0. There's no point in writing it in. If we add 0, it's not going to do anything. So that's what's happened there. There is a plus 0 that's not doing anything. So this leaves us with a nice equation. 5 minus 2x equals 0. How do we get rid of that minus 2x? We don't want it on the same side as the 5. We want 0 of them. So just add on 2x, you'll get 0 x's on the left. But if we do that on one side, then we're adding 2x on the other side. So 0 plus 2x is 2x. So we have 5 equals 2x. So I only want 1x, I don't want 2 x's. So I'll divide 2 by 2. So I'm dividing by 2 on both sides, of course. So that's 5 over 2, or 2.5 if you prefer. Leave it as 5 over 2 if you want. Similarly, over here, we were saying that x is equal to 0. This bit here. So our x becomes 0, so it's minus 2 times 0. Well, 2 times 0 is still 0. So we're subtracting 0, which is not going to do anything. So we now have this nice equation here. It's kind of easy to solve that. Again, we don't want the 5 there. I would like to get 0 here, 0 numbers. So I'm left with only y. So how do we get 0? I subtract 5. And I do the same over here. So 0 minus 5 is minus 5. On the right, we're getting minus 5. And we're left with only y here. Y is equal to minus 5. Let's stick it in. Y is minus 5. So they're the 2 points where this line L crosses the x-axis and y-axis. Next question. Find the slope of the line L. 2 ways you can do this. The first way is to get the line in the form y equals mx plus c, which is what we've gone for here on the left. So we're going for the slope intercept form so that we can get the slope that way. So again, we don't want everything on this side. We want to get y isolated on its own. So I don't want the minus 2x. I'll add 2x to get 0. You can see there's 0 x's here. 0 x's. But that means I add 2 x's over here. 0 plus 2x is just 2x. So that's our first step explained. Okay. Now again, simply we want the y on its own. We don't really want this 5 here. So I'll subtract 5 to get 0. But that means I have to subtract 5 over here. Give me 2x minus 5. So I have 2x minus 5 is equal to y. I can pick out the coefficient of x. That's my slope. Slope is 2. Question answered. Alternatively, another way is a different way to get the same answer. Same equation at the very start. This time I'm just going to rearrange it a little bit. I'm not doing anything to either side. I'm literally just rewriting the order of the terms to create this line here. Okay, so nothing done to either side of the equation there, just reordering everything. But I can see now if I compare that to the normal equation, which is often written ax plus by plus c equals 0, I can see that a is minus 2 and b is a positive 1. So the a is minus 2 and the b is the invisible positive 1. Okay, so we have our a and our b. So we can use this together with this slope formula. Slope is equal to minus a over b. We always say rise over run. It's the same thing though. Minus a over b. So the minus is going to be there from the formula. But I have my a in here, which is minus 2. And we have the b on the bottom, which is 1. So we have our pieces in there. The one thing to watch here is that minus by minus makes plus. Okay, that invisible 1 there, of course. Minus 1 by minus 2 gives you plus 2. And indeed, 2 divided by 1 is just 2. So our answer is 2 there. Slope is 2. Getting the same answer regardless of how you solve it. Next, the line J goes through the point 11, 6 and is perpendicular to the line L. Perpendicular means 90 degrees, of course. and we're using this symbol here for perpendicular, upside down t. Slope of L, okay, written m little subscript l, so we can write the slope of L like this. Okay, slope of L. We found it was 2 in the last part of our question, so we've had the slope as 2. I'm just going to rewrite it as 2 over 1. Indeed, we saw it written as 2 over 1 over here, didn't we? So writing it as 2 over 1 just makes it easier to find the perpendicular slope. How do I find the perpendicular slope? We flip this upside down. So instead of being 2 over 1, it's now 1 over 2, having been flipped upside down. The other thing we do is we change the sign. This was positive. You'll see it's now negative. So we flip and change the sign. That's what we're doing, guys. Flip and change the sign. So it's now minus a half instead of 2 over 1. Okay, next we have to find the equation of line L. Equation of line J. We have two pieces of information. From the last part of the question, we found slope of J was minus a half. And also we were told the point 11.6 is on J. So we have this piece of information here. That can be our x1, y1. So we're going to use that x1, y1 in our formula. This is the general equation of a line formula. So I've prepared an empty formula here where I've left out the slope, I've left out y1 and x1, but we can fill all that in now. So we can fill in the different bits. I'm going to put in the minus a half for the slope, and for y1 we have the number 6 here. Okay, so number 6 is going to go in here. For x1 we have 11, so that can go in here. Have that filled in as well. So we have a big note about multiplying both sides by 2. I'm going to show that on this side as well, of course. Multiplying both sides by 2. That's where the blue 2 came from. And you might ask, where's the multiplying by 2 on the right hand side? And indeed, where's the half gone to? Well, there was the half, wasn't that? It was in that position. But if I multiply that by 2, I'll be doing 2 divided by 2, which will be 1. If you multiply by 1 or divide by 1, it's not going to have any bearing. It's not going to change anything. So really that's why they kind of cancel or undo each other. So I need to put my 11 down there, of course, and my 6 down there as well. Okay. Now if we go multiplying those, 2 by y, 2y, and 2 by the minus 6 is giving us that minus 12 there. Okay. On the right hand side, similarly, minus 1 by x, giving us that minus x there, and we get the plus 11 from minus 1 by minus 11, giving us that plus 11. So that's our multiplication done. Now we want to leave our equation looking like this rather than this. So how do I make that adjustment? Again, I want 0 on the right hand side. That means I want to get rid of the minus x and I want to get rid of the plus 11. So how do I get rid of them? Minus x plus x gives me 0. So the x's are gone. But if you do it on one side, you have to balance the equation by doing it on the other. So it's there's our plus x coming from there, where there was no x's. We've added an x. So we've got 1x now. Similarly, we need to get rid of this 11. And we subtract 11 to get 0. You can see the 0 this time. So we have to do the same thing on the other side. There's my minus 11. Taking that from minus 12 gives us minus 23. Don't be afraid to use your calculator and make sure you get it right. Okay, hope that was helpful, guys. Take care.